So welcome to ExamLearn's videos on logs and indices. Quickly, I'm just going to tell you a little bit about ExamLearn. So we're a website that does loads of free features like exam topics and exam papers, and as well we have A-grade notes. So here's the logo up in the top right corner, and there's a link in the description. So if you want to go onto that website, you can see all the free features you have, or else you can sign up and pay for the A-grade notes for every subject. But anyway, we're just going to go ahead with these videos now. So we're going to talk about indices in the first few videos. So indices is just another word for powers. So for example, x squared, x cubed, x to the power of 4, and so on. So that's all indices or powers. And all the rules for indices, they're in the tables book. So I have the rules listed here, and I'm going to go through each one of them. But the whole trick of this question is just using each one of the rules. So you can turn something really complicated and just pick apart one piece at a time using each one of the rules, and then you can make something really complicated into something really simple. Anyway, I'm just going to start with going rule one by one, and then I will show an example for each rule. So for the first one anyway, if we have a to the power of p multiplied by a to the power of q. Actually, sorry, before I start, all of the numbers here, they all have to have the same base number, so it always has to be a on the bottom, or else, as long as it's the same number, it doesn't have to be a, it can be a number, it can be x, but as long as it's the same for both kind of numbers, then you can use these rules, otherwise you can't. Anyway, if you have a to the power of p multiplied by a to the power of q, then it's a to the power of p plus q, so you add the powers together. So an example would be if you had x squared being multiplied by x cubed, and that dot just means multiplied, then your answer will be x to the power of 2 plus 3, or else x to the power of 5. Okay, so that's the first rule, and that's as simple as that. Just all the examples are going to be like that. Then if, for example, if you have, I don't know, x to the power of 6 divided by x to the power of 4, use the second rule, the answer is going to be x to the power of 6 minus 4, which is going to be x squared, or x to the power of 2. Yeah? And then the next example is going to be a to the power of p all to the power of q. Okay, so that's one power to another power, so a to the power of p to the power of q. That's going to be a to the power of p multiplied by q, and that's equal to just a to the power of pq, or just p multiplied by q. So that makes more example with the number. Oh, sorry, I meant to do that without numbers, my mistake. So if you have, say, x squared multiplied by x cubed, then that's going to be just x to the power of 2 multiplied by 3, which is equal to x to the power of 6. Okay, so you just ignore that bit there. Yeah, so that's the example of this rule here. So I'll go on. I'm going to change color to purple. If you have anything to the power of 0, it's equal to 1. So for example, just 3 to the power of 0 is going to be 1, or even if you have 1,000,000 to the power of 0. So 1,000,000 is 6 zeros. To the power of 0 is equal to 1, and you can check that in your calculator. That's just one of the rules of indices or powers. So I'll scroll down a little bit more. Okay, if it's anything to the power of minus p, then it's 1 over a to the power of p. So the minus is just going to make it turn into 1 over, and the p, or whichever number it is, still stays there. So for example, if we have 6 to the power of minus 2, that's just going to be 1 over 6 squared. So the minus makes it 1 over, and then the 6 squared still stays, so you can change that if you want to 1 over 36. Again, same thing if you have x to the power of minus 2, that's just 1 over x squared. Okay? Next example then, I'll do one more purple example. If we have ab to the power of p, so all to the power of p, that's equal to a to the power of p and b to the power of p. So the example I always do for this, if you have xy squared, okay, the answer to that is x squared y squared. Okay, just be really careful, because that isn't the same as, and this symbol means not equal to, so equal to and then a line through it, is not equal to xy squared. Okay, so a lot of people just think, oh, xy squared, that means both of them are squared, but they're two very different things, because in this one it's x squared and y squared, and in this one only the y is squared. Yeah, and it's the same, that is also not equal to x squared y. Yeah, so they're all very different things. The answer to this one here, xy all to be squared, is x squared y squared, and not these ones here. So I'm going to put a line through them. Yeah, so don't make that mistake. It's a mistake a lot of people do make. The next one, for example, a over b all to the power of p, is you just put each one to the power of p. So a to the power of p over b to the power of p. So for example, if you had 3 over 4 squared. The answer to that is just 3 squared over 4 squared, and that's just 9 over 16. Yeah? Okay, and now here's the last one. So there's one more rule after this. It's this and another one, and these are the most difficult rules. So the rule reads a to the power of 1 over p, so it's a fraction, is equal to the pth root of a. So the pth root. Okay, so what do I mean by the pth root? So I'll do some examples. So 4 to the power of a half, okay, is equal to the square root of a, or the second root, yeah? So you say the square root, is of 4. Yeah? So we don't ever write the 2 in front of that root there. Normally we just write it as the square root of 4 like that, okay? And we know the square root of 4 is equal to 2, because it's what number do you multiply by itself, or what number do you square to get 4? So 2 squared is equal to 4, so the square root of 4 is 2. So hopefully that wasn't too confusing. It's kind of hard to say. But also there's more than just the square root. So for example, 8 to the power of 1 over 3, that's equal to the cubed root of 8. Okay? So you see here that whatever number's in the bottom of the fraction goes in front of the root there. So 1 over 3 is equal to the cubed root, and this time you do have to write the 3. So you don't have to write the 2 just because we use the 2 most often, but the 3 you do have to write it all the time. So the cubed root of 8 is equal to 2, because 2 cubed is equal to 8. Okay? And then again, you can keep going in this fashion. So you can have 16 to the power of 1 over 4 is equal to the fourth root of 16. And that's again equal to 2, because 2 to the power of 4 is equal to 16. So it keeps going like that. So basically what this rule means is if you have 1 over a number, then it's as in if a is to the power of 1 over a number, then it's that number root, or the pth root, if you will. It's kind of hard to say. So the last rule then is just a slightly more complicated version of rule number 8. So if we have a to the power of q over p, so it's kind of hard to write so many small indices like that, but that's a to the power of q over p. Okay, the answer is going to be, so it's going to be the pth root of a all to the power of q. Okay, so I'll give an example of that. So for example, if they ask us 8 to the power of 2 over 3, okay, and I'll just say before this, so it's whichever number on the bottom, so it's 8 to the power of q over p is the pth root to the power of q. So I'll say number on bottom that goes before the root. And then the number on the top, this is of the fraction there. So talking about here, number on top is the power. Yeah, so it's to the power there. But anyway, 8 to the power of 2 over 3. So we're going to apply the rule. We're just going to write that as, so the number on the bottom goes before the root. So 3 is going to go before the root of 8. And then q goes outside that to the power of 2. Yeah, does that make sense? So you're always going to just, that's the hardest one to be honest. I'd always just look at the log tables, look at your tables book, write that formula out above it, and then it should be clear what you're supposed to do. So now if you want to solve this, I'll just go to orange. The cubed root of 8 is equal to 2, because 2 cubed is equal to 8, and then 2 squared then is equal to 4. Yeah, so I'll go through kind of all of these. There's a few of them you kind of have to learn off or just recognize, and it makes these kind of questions a lot easier. But hopefully that makes sense, doesn't it? And just one quick thing I'll mention. So I'm always writing it in this form. However, there's another form of the rule as well. So you can either write it as the pth root of a and that all to the power of q, or you can write it as, again, it's still the pth root of a, but it's a to the power of q. Okay, so it depends which order that'll actually give you the same answer. It just depends what order you want to do it in. So for this question here, if we tried to do it in this order, so if we had 8 to the power of 2 over 3, so again it's going to be the third root of 8 squared. Yeah, and we can do it like that as well if you want. So you'd have then, so you have to do this little sum in the middle. So 8 squared is going to be 64. and now you have to find the third root of 64. If you can do it in your head or do it in a calculator, you're going to find your answer is 4. So it's the same answer. So at that point, I just wanted to make that you can either use this or this version, but sometimes it's much easier to use this version. Sometimes it can also be easier to use this version here. So it does depend on the question. I kind of stick with this one anyway, generally. So I'm going to finish it up there because the video is getting quite long, but hopefully that all makes sense. And sometimes you'll have to do these without a calculator, so you do have to know which one goes in which direction. So they'll ask you to do it without a calculator, which means you have to show your workings here. So you can put it straight into a calculator, but it won't always work for you. So again, hopefully that helped. I just went through quickly all of the rules. We're going to look at harder examples in the next video and mixing the rules all together. So hope you enjoyed that. We'll see you in the next video on indices.